So here's our last topic in Unit 3 Chemistry, and we're going to review this for 3 minutes. This is electrolysis. What's the fundamental things about electrolysis? It's based around redox theory. So you need to understand your oxidation numbers. You need to understand how to balance half equations. You then also need to understand an oil rig cat. That means anode is where oxidation happens. This is loss of electrons. Cathode is where reduction happens. This is the gain of electrons. You need to understand that how you use the electrochemical series does not change from year 11 all the way through to here. The strongest oxidant is a thing that's always going to react, which is the highest thing on the left-hand side of our periodic table, and the strongest reductant is still going to be the thing that reacts, which is the lowest on our right-hand side of our electrochemical series. The one thing you need to be kind of careful of is the fact that in electrolysis, you're putting energy into a system, whereas in galvanic cells, which we did before, you're getting energy out of a system. So therefore, in electrolysis, you're converting electrical energy into chemical energy, whereas in galvanic cells, you're converting chemical energy into electrical energy. So know the difference of those two. You also need to understand there's one change between a galvanic cell and an electrolytic cell. That is the polarity of our electrodes. In a galvanic cell, the cathode is positive, red cats are happy. In an electrolytic cell, the cathode is negative. Red cats are sad because you're putting electricity into them. That's how I remember it anyway. We looked at 4 main applications to do with electrolysis: how we do electroplating, how we do electrorefining, how we do metal production, and how we recharge batteries. So you need to be aware and write some notes about how each of these work and what the foundations about designing a cell for these purposes are. The fundamental thing for the first 3 of these is the fact that you're creating a metal, and that's reduction, and that's mostly going to happen at the cathode. The fundamental thing about rechargeable batteries is that the reactions are going to reverse through the discharge reaction. So discharge, where you're producing energy, you're going to have a reaction happen. When you recharge it, you flip that reaction around and you are pushing energy in and driving the products from that back into reactants to then be able to use again. You then need to understand some applications of Faraday's laws of electrolysis, and this sounds complicated, but it's really not. It's all to do with how much mass is produced at the cathode in an electrolytic cell. Now, it comes down to 2 things. One is how long you leave the cell running for, or how many amps you put the cell on, because this is about electrical charge. The more amps or the longer the time, you're going to get more mass produced. This is his first law. The second law is about the charge on the ion and how many electrons it takes to produce your metal. So understand these 2 basic laws. Then you need to do some calculations, and here's some equations you need to write down, and think about the ratio of metal to your electrons when you're doing these equations as well. Lastly, some basic generalizations which I've already touched on with the applications of electrolysis. And once again, no time for my top tips, but I'll put all the top tips from all these 4 topics in the one video next.